This is a short video to talk about two examples of enthalpy changes for specific changes, and that is when things are dissolved, they make a solution, and when things are diluted. And the first one is the heat of solution, which is simply the enthalpy change that occurs whenever a substance dissolves. So it is the delta H when a substance dissolves. And we're generally talking about in water. Alright, so let's look at an example of sodium chloride. In a separate video entitled Solutions and Dilutions, we talked about the fact that when sodium chloride dissolves, it separates into its ionic components, Na plus and Cl minus. And the process of that turning from sodium chloride, a solid, into those dissolved ions would give us an enthalpy change, and that's known as the heat of solution. All right, and we can think of this whole process as being in two parts. The first part is a step in which the sodium chloride solid turns into separated ions, and if they're completely separated and not yet in the water, they would be gas phase. So it turns into Na plus gas plus Cl minus gas. And that energy associated with that change is known as the lattice energy. All right, and then we can do a second process going from those separated ions and making them aqueous ions. So they are surrounded by water, and we also talked about that in the same video, Solutions, Dilutions, and that energy change is known as the heat of hydration, which can be written delta H hydration. All right, so that's a separate process, and as we know from Hess's law, that if we can separate one reaction, this one that we want, into two reactions that sum to it, then we know that the delta H's for those parts will sum to the delta H that we want. All right, and another thing to keep note of is that the lattice energy and the heat of hydration may have magnitudes that vary for different substances, and so if we're going to add them, we're going to get the heat of solution is going to equal the lattice energy plus the heat of hydration. Those two parts, that's Hess's law, so you can add them. If you add the reactions, you can also add the heats, and since we don't know the relative magnitudes of these two, for different substances you will get an overall positive or negative value for delta H solution depending on the values of the other two. So sometimes heat of solution is positive, things dissolve and the solution gets cool, and sometimes it's negative and they dissolve and the solution gets warmer. So it can go either way. Similarly, we have the heat of dilution. Okay, so that is the change in enthalpy when dilution occurs. So dilution occurs whenever you add more water to something that's already in water. And what that will affect is mostly the heat of hydration. Okay, so the heat of hydration will be different because you're adding more water, so there's more water to hydrate around each ion, whereas the lattice energy won't change much. So the major change between the heat of the major change in the heat of dilution is going to be because the hydration changes. And because you have a slightly different heat of hydration than you did for just making the solution in the first place, that means when you dilute a solution, you might get a change in heat slightly.